Hello and welcome back to Steam It with Steve. Today we're going to go through how data dictionaries work, which are an important case tool when we're looking at our new programs and how all the data sort of connects together. So let's jump on in. So data dictionaries, like I said, are basically a tool that you use when you're trying to map out all the variables that you're going to use in your program. It's a really useful tool to sort of get that mud map together, and then you can understand all the data types that you're going to use and how they interact with each other. So the learning intentions for today, basically we're going to go through and understand what a data dictionary is and its significance in managing data. We're then going to learn the components of a data dictionary, including the variable name, data type, format, and much more. We're then going to create a basic data dictionary for a hypothetical application, and then explore how data dictionaries facilitate excellent data management when we're dealing with programming. So first, a bit of a definition. What is a data dictionary? Well, a data dictionary is a comprehensive description of each data item inside of a system. This is particularly useful when we're dealing with databases. So it includes the variable name, so the variable that you write or the identifier, the data type, so is it a string, integer, floating point, or a boolean, the format that you're going to use, the number of bytes that are required for storage, the number of bytes that are required for display, the description of the purpose, and then an example, and then a little bit of validation at the end. Now, those are the key points in the questions that you get inside of Nessa style exams. They might not use all of those, but you do need to be aware of them. So let's jump in with an example because that's easy to sort of get your head around this. Here's a pretty typical example of a data dictionary. So what you'll see on the top left here is the data item, and then all the variables are listed down here. You'll then see the data type. So in this case, a user ID is a string, first name is a string, a surname is a string, and then a date of birth is a little bit different. It's actually stored as a floating point number. Now this is being formatted as a date format, and basically the floating point number allows you to store a really big number, which tells the system how to store it. Then you've got integers, floating points, and then booleans down the bottom. As the format, it then describes how the output should look. So if the user ID should have a letter and a letter, which is what the X's stand for, and then three numbers, which is what those N's stand for. The first name and surname doesn't exactly have a format, and then the date of birth must be the year, month, then date, with backslashes in between. The number times late is NNN, and then the pay rate you'll notice has a $NNN.NNN. So that's the number, but it has to have three numbers before the decimal point. Union member has to be a letter, and so on. So then we have the number of bytes and the size for display. So a string generally has 1 byte per character. So in this case, we've got 5 characters, so that's why it requires 5 bytes. And then the same for display. That's the same for first name and surname, but then date of birth is a little bit different. So you notice here that it's stored as a floating point. A floating point only requires 4 bytes, which is why that's quite small. But then when you output it for the size of the display, you can see that it has to have 10 characters, or 10 characters that go inside the string. So because of that, if we go through it, that's why that's gone 4 to 10. Same with times late as an integer, you can store them as 2 bytes. And then, but for the output, it needs to be stored with outputted with 3 characters. Same again with the pay rate, with floating point stored as 4 bytes. But then the output, if you look here, it's got 7 bytes for the 7 characters that need to be outputted. The description then is pretty obvious. It just goes through and describes what has to happen. And then under the example, it goes through and gives a little example of how the output would look. The last column is pretty cool. That goes through the validation, which is pretty much like a conditional statement. That then describes the if statement that has to validate and check to see whether or not the input the user is given is valid. So for example, for the date of birth, it can't be in the future, which is why it must be less than today's date. The times late needs to be an integer between 0 and 999, and then the pay rate has to be greater than 20 and then less than 400. So getting $400 an hour is pretty excessive. That's why that's as late as it can go. Awesome. So I'm going to unpackage a little bit more each one of these just so that it's been described. So for the data item, basically it's a variable, so that's the identifier, and it's going to be the name of the item to be stored inside of your program. It's important to make sure that these are named appropriately, and when we use Nessa's guidelines, we need to make sure that we're using Pascal case. So that basically means a capital letter for each word, and then no spaces in between. Then we've got floating the data type. So the data type in this case was the floating point. So a data type is the way that the item is going to be stored. So some examples include strings, integers, booleans, floating points, and then you can have more exotic ones. So for example, a floating point with the data date format, an array string, array of records, a record, and then also a file stored in sequential format, which we'll deal with later. You can then deal with the format, so that's the way that it's going to be displayed on the screen. So X's represent characters, where N represent the numbers that you're going to deal. So for example, year as well, you can use that for date, and then there was the pay rate, and then there was the ID. Then the number of bytes required for storage, like we've talked about, is based on the data type and the format that's going to be outputted. So for example, a boolean only requires 1 byte. It's either going to be true or false. Technically, it's only really 1 bit, but we've got to round it up to the whole byte. A character, which is the letters, is going to be 1 byte. A string is however many characters times 1 byte. An integer will store with this system is 2 bytes. You can also store an integer as 4 bytes if you want to store a larger number, so from -2 billion all the way up to 2 billion. And that's just because you have more memory stored with it. A floating point is a little bit more different. So it's also 4 bytes, but it's able to store significantly bigger and smaller numbers. This is a little bit more complex behind the math behind how that sort of looks, but you just need to sort of accept that the floating point works like that. If you want to have a look at that, just do a Google search on how floating point numbers are stored. Then you can have a double floating point, which then increases the amount of bytes. So then it also increases the size. So that's when it gets ridiculous. So you can store up to 10 to the -308, which is a really small number. And then 10 up to 308, which is, again, really big. Floating point and double floating point also have a precision issue. So for floating point, it's only accurate to 6 decimal points, and for double floating point, it's only accurate to 15 decimal points as well. And that's sort of that scientific notation that you might have seen before. You then have arrays of data types, which is assigned the appropriate bytes. And then you've got exotic data types that need to work out how many bytes need to come with it. The size for display, well, that's what we've talked about before. So with this pay rate example, there was 7 characters that need to be outputted. So it's just counting how many characters need to be outputted with it. So they convert it to a string. So basically the amount of bytes is determined by the length of the string. So simple data items can be displayed generally as the same amount of bytes for storage. So for example, gender needs 1 byte. So then that's either going to be male or female. Complex data types need to be displayed, need a bit more wrapping around it. So for example, pay rate needs 4 bytes to store it, but then 7 bytes to output it. Then the description, so this just creates a meaning overview of what the data item is, and then this can include any constrictions that happen on the variable. So for example, user ID has to have the first letter of the name followed by 3-digit identifier. Then the example that we have, so then you can come through here, this is a practical example showing how the data item should look. And then lastly, you've got the validation rules. So it's any rules that are associated with the program, so it knows that it's valid entry. So for example, date of birth needs to be less than current date. And then you just leave it as empty if there's no validation that's needed. So hopefully that's giving you a nice overview of a data dictionary. There's a really good video that another person's made, which I've put in the link in the comments below. I'd follow that and have a quick look as well, just to sort of back up, and that's usually what I do in class as well. So now to unpackage a few others. So this was a really cool one that I found from NESA. So this is a NESA example straight out of I think it was the course specifications. So you'll see that it has a few more things in here. So departments is stored as an array of strings. So this is, it looks like a teacher database. So 20 times the number of departments, because that's how many there are. And then you got upper limits, the tax rate stored as a percent. And then they have really cool little descriptions over here as well. So that was the first half that you've seen before. And then there's a bit more down below. So got a few questions straight out of NESA exams. So let's have a look at them. So which is the following is the most appropriate data type for storing telephone numbers? So just pause the video, have a think. Awesome. So a common mistake is people will say integers, but then they don't consider, you might use brackets, you might have the plus symbol at the start. So you actually need to answer that as A. So it's one of those little sort of trickier questions. Here's the next one. So this one has a program required the use of 3 variables. So weekday, is daytime, average temp. Which of the following correctly shows how these variables are described in a data dictionary? And notice how it's not describing every single column we saw before, but potentially you could get one. So just pause the video, have a go, read through it. Probably can't see that bottom corner one. There you go. Awesome. So what you should see, you've got weekdays, is day time, and average temperature. So weekday is going to be stored as a string. That's the same in all of them. Is day time would be probably a boolean. So then that means it's either A or B. And then the average temperature, well, average temperature can be stored as a, I'd be doing a floating point. So I would say that would be A. 22. So your software company has been contracted to create a web-based system which will allow job seekers to make themselves known to potential employers. The following features are needed for this system: a registration process for new employers, a registration process for new job seekers, a single data store for registration details of all existing users, a secure login for existing job seekers, a secure login for existing employers, a search engine that allows employers to find potential new employees, and then once registered, job seekers can submit or update their resumes. Create a partial data dictionary for the registration data file, showing 2 different data types. So this is a partial data dictionary, so it doesn't have to be super detailed, but you have to show the data type. That's the important bit. And then this was what the sample answer was. So it had username and user type. The data type was a string and a boolean. So because there had to be 2 different ones. And then the string for username, they said 20 bytes, so 20 characters. And then boolean was 1 byte. So for either job seeker or employer. That's the sort of style of question you're going to get. Another one that's a little bit more complex. So the following diagram shows the structure of Acme's Golf Club's website. So welcome to Acme Golf Club. It's got a menu, then a login, then the membership rules, the new member data entry, and then a help screen. A new member data entry screen is used to collect general personnel details, including ID, given names, surname, gender, date of birth, and so on. Sketch a design for this screen and label any key interface designs. We're going to skip that, and then we're going to go straight to creating a data dictionary for the data to be entered into the new member entry screen. Cool. So pause the video, see if you can build the data dictionary for that, and then you should see there's the IDs there, clearly all the things that need to be entered in. Awesome. So what you should have found is something like this. So it had the field name, the field size, the data type, and then a quick little description about it. So as long as you provided a substantially correct data dictionary, you got the 3 marks, which is pretty cool. Awesome. So here's another challenge that I have for you. So Bond University is enrolling students and needs to create a data dictionary. A student has 9-digit student ID, a surname, and a given name. They must also provide a date of birth, a valid email address consisting of student number, and at bond.edu.au. Their gender can be male, female, other or undisclosed. Students can apply to study either full-time or part-time. There are 12 faculties at the university. Each student must be in 1 faculty only. So have a go, try and build the data dictionary for that. Just pause the video, have a go. Awesome. So what you should see is this. So you've got the data item, the data type, the format, the number of bytes required, the required for storage, the size of display, description, example, and validation. My advice is when practicing data dictionaries is to learn all 7, just so that you've got that skill set, so you're not so confused when it comes to the exam. And then this is what I built. So I had the student ID and then pretty much just made up some things just so that it was consistent. You can have a look at that. Oh, sorry. Move it out of the way so you can see that bottom corner. Yeah, pretty much went through things that were unique. In this was the student ID. It was either stored as an integer, and then the surname was the same. The date of birth using the date format was pretty much the same. So validation was that had to be 9 characters long. Validate less than the date, must start with 9 numbers and must end with @bond.edu.au, and students can only enroll one faculty at a time. So hopefully that gives you some ideas of how to build your own data dictionaries. So some conclusion questions to think about. How can data dictionaries improve the efficacy of databases or the programming that you're going to be doing? Can you think of real world application where a data dictionary would be crucial? And then how would you explain the importance of a data dictionary to someone unfamiliar with programming? So I've built a little Kahoot there that you can sort of play around with. Um, and yeah, hopefully you've enjoyed that. So that should have given you some pretty good ideas of how a data dictionary looks and how to sort of put it all together. My advice is play around with this more so you can understand how the structure works. But by having that key grid with the 7 different columns, definitely will help you understand. And yeah, basically, even using AI and ChatGPT can help you generate some questions and get your brain thinking how a data dictionary looks. If you enjoyed this video, please like and subscribe down below. It really does help with the YouTube algorithm and helps me out a whole heap. And hopefully you've enjoyed. Thank you very much. See you next time on Steam with Steve. Adios.